Hello everyone, I am James C. Baclan and welcome to the finals of our EE311. And I would like to thank our instructor, Engineer Marjon Gimpayan, for teaching and instructing us in this subject. So let's proceed in answering the questions. Questions 2 and 3. A cutting tool exerts a tangential force of 400 Newton on a steel bar of diameter 10 centimeters, which is being turned into a simple lath, and the lath is driven by a chain at 840 rpm from a 220 volts DC source. If the motor efficiency is 80% and runs at 1800 rpm, then calculate the current taken by the motor. So we have there the choices. Now we have the formula T is equals to force times D, and our force is already given 400 Newton. Then our D, or the distance, we have that in radius, and since our given is in diameter and it's in centimeters, we convert that first to meters. So 10 centimeters is equals to zero point 0.1 meter. Then convert that to radius. We simply divide that to 2. We should have 0.05. Then multiply by 400. Then we get 200 Newton meter. Now for our P output or output power, we have the formula 2 pi times speed times torque over 60. And 2 pi times our speed, which is already given, 840 rpm, times the torque that we solve, 20 over 60, we get 1760 watts. Now for the efficiency of our motor, that's equals to power output over power input. Our efficiency is already given, 80% or 0.8 equals to 1760 watts over power input. Now we have power input as 2200 watts, and power input is also equals to V times I. Now 2200 watts is equals to the given voltage 220 volts times I. Then our I will be 2220 watts over 220 volts, and that's equals to 10 amperes. Letter D. Now for our question number 3. What size is the motor pulley if the lath pulley has a diameter of 24 centimeters? We have there the choices. Now we let N1 as the speed of the driver pulley, D1 as the diameter of the driver pulley, and our N2 the speed of the lath pulley, and D2 as the diameter of the lath pulley. Now we have the formula. The product of the driver pulley's speed and diameter is equals to the product of the lath pulley's speed and diameter. Now we have our speed of the driver pulley, which is 1800 times the diameter, which is equals to 840, the speed of the lath pulley times its diameter, which is 24. Now we have D1 is equals to 840 times 24 over 1800. That's equal to 11.32 centimeters. Now for question number 4. A 500 volt shunt motor runs at its normal speed of 250 rpm. When the armature current is 200 amperes, the resistance of the armature is 0.12 ohms. Now calculate the speed when a resistance is inserted in the field using the shunt field at 80% of the normal value, and the armature current is 100 amperes. We have there the choices. Now first we find our E1. That's equals to, based on the illustration, we have 500 volts minus the voltage passing there, that's equals to 200 amperes times 0.12 ohms, that's equals to 476 volts. Now when the current changes to 100 amperes, we have 500 volts minus 100 times 12, that's equals to 488 volts. Then we have the equation EB1 over EB2 is equals to flux times speed of the of the first one over the second flux times the second speed. We already solved the voltage 1 and voltage 2, that's 476 over 488 is equals to, we cancel the flux, is equals to 250 over 0.8 times the second RPM. That's equals to N2 is equals to N2 is equals to 488 times 250 over 0.8 times 476. We should get an RPM of 320. And that's letter A. Now for questions A to 11. A series motor having an armature resistance of 0.1 ohms and a field resistance of 0.15 ohms takes 48 amperes at 230 volts and 720 RPM. The total core and friction losses are 650 watts. Now, calculate the developed torque. So, we have E is equals to 220 is equals to VL minus the armature resistance times the armature current times the quantity of the armature resistance and the field resistance. That only applies to series motor. So 230 volts minus 48, it's already given. The armature current and the resistance and the field current are already given. So that's 48 times the quantity of 0.1 ohms plus 0.15 ohms. Then 0.1 plus 0.15, that's 0.25 times 48. That should be 12. So 230 minus 12, we have 218 volts. Now next is, we know that power is equals to VI, voltage times current, or EI, which is also equals to 2 pi times speed times torque over 60. So our volts is 218, then the given current of 48, which is equals to 2 pi, and the given RPM or speed 720 times torque developed over 60, and that's equals to T developed is equals to 218 times 48 times 60 over 2 pi times 720. We should have a torque developed of 138.78 Newton meter. Now for question number 10, find the percentage change in the torque. So torque is equals to constant times flux times current, and that flux is equals to constant times current. Now we input the flux to the torque equation. We have torque is equals to K, or constant, I squared, since from the flux we have K times I. So that becomes I squared. Now we have the formula T2 over T1 is equals to IE2 over IE1 squared. And our T2 over T1 is equals to our IA2, that's the current when the load in the motor is reduced. That's from question number 9, and that's 32 over 48, the given current. So our T2 is equals to 0.444 T1. Then we plug in that to the formula, which is percentage change in torque is equals to T2 minus T1 over T1 times 100%. And our T2 is 0.444 T1 minus T1 over T1 times 100%. Then 0.444 minus 1 is negative 55 is negative 55 6 0.444 minus 1, 0.444 minus 1 is negative 0.556 over T1 divided by 1. We have negative 0.556 times 100, that's equals to negative 55.6%. Then the negative sign indicates a decrease in the load of the torque. So we have the answer of 55.6%. Now for question 11, calculate the efficiency of the motor when delivering one half of the rated torque. Now, the same formula used in question number 10, T half load over T rated is equals to IA half load over IA rated squared. It stated that our T half load is 0.5 of the T rated, so 0.5 torque rated over torque rated is equals to IA half load over 48 squared. So our RA half load is equals to 33.94 amperes. Now for our input power, when it's half load, we have V times I, or is equals to, our voltage is 230 volts, it's already given. Then the half load that we solve, which is 33.94 amperes, multiply that, we have the power of 7,806.2 watts. Now for our efficiency when it's half load, we have the formula P output over P input, and that's also equals to P input minus the power loss minus the core and the friction power losses, and over the input power. So we have our half P input when it's half load, that's equals to 7,806.2 minus the power loss, or that's equals to I times R. Our I is 33.90, I squared times R. Then our I is 33.94 squared times times the resistances, 0.1 plus zero point 0.5 or 0.25 minus 650 watts. That's already given. Over the input power, 7,806.2 watts times 100%. So we should have the efficiency of 88%, or letter B. That would be all. Thank you.